All right, so I'm Joe Conway, the VP of Engineering for CrunchyData. If you take just one thing away from this brief talk that I have, if you're thinking about Postgres, microservices, OpenShift, and security, you want to see Crunchy. Crunchy has led the market with Postgres when it comes to security. We are the author of security benchmarks for the US government, for the CIS, the Center for Internet Security. We've got a common criteria certified version of Postgres, which essentially means extensive testing to validate the security, as well as the fact that we literally look at every patch that gets committed to Postgres or PostGIS or several other components that are part of that suite of tools. So when it comes to security, we've got that in spades. We've also got, and what I'm going to spend most of the time talking about for the rest of the slides, we've got not only a very robust containerized solution of Postgres, not just standing up a database, but standing up an entire HA cluster with integrated backups and integrated monitoring and basically all the things that you'd want to run a database as an enterprise. We've got containers for that, but more importantly, we also have an operator that allows you to orchestrate many, many clusters of databases. Our model is that everything we distribute is based on pure open source, so there's nothing proprietary. You can get all of our containers and our operator right off of GitHub. It's GitHub/CrunchyData. And basically we sell subscription support for that. So briefly, an operator, I assume most of the people here probably know what this is, but an operator is basically an application controller that lets you orchestrate nuances, and especially with stateful services in Kubernetes or an OpenShift environment. And basically our operator, the Crunchy Postgres operator's short name is PGO. It can be accessed via a REST API, and there's a diagram on that a little bit later. It includes full built-in RBAC, so it makes full use of the RBAC available in Kubernetes and OpenShift, and it communicates directly with the Kubernetes API. Why would you use it? Well, if you've got complex operations, which you typically do with a database, this reduces those complex operations down to one-line commands. It lets you do many different customizations to various database clusters that you might need to work with, and you can still use the same workflow. As I mentioned, we have a simple CLI that's available, a command line interface, but because that interface is actually built on top of a REST API, we also have a GUI that we can lay on top of that, and later on maybe further integrations with things like the OpenShift GUI. It allows you to manage at scale, so you can manage potentially thousands of different database clusters, and we have customers that are actually doing this at this kind of scale now, both in the commercial world and in the government. And as far as, again, security, by having the operator, you don't have to give full access to your OpenShift cluster in order to manage the databases. You can give specified least privilege access to operators who are going to users who are going to use our operator in order to orchestrate your cluster. The value of OpenShift for managing Postgres instances basically goes up exponentially as the number of instances of the database increase. And what this operator basically boils down to is we are Postgres experts. Our company actually is responsible for about a third of the code that is in the upstream Postgres database. I'm a committer. We've got several other committers on staff. We've got the person who's founded the PostGIS spatial extender for Postgres is also on our staff. So we've got extensive expertise in this. That's been boiled into the operator so that you can basically be very productive and be very successful in your deployments. So it's been GA since 2017. So as far as operators go, it's actually been around for a while. And it's very robust, and it's been used in production, and it continues to get developed based on direct feedback from users. So importantly, the features that are in there have been driven by real users with real production needs. These are some of the things that it can do: create basically an HA cluster, scale up and down the number of replicas. It automates the high availability. It automates the backup. You can apply security policies across the board or based on namespaces. You can define resources, and it also does some smart deployments in terms of using node affinity to allow you to specify where things go. Here's some examples. PGO create London will just create a pod. It's basically an HA database cluster, one simple command. Set up, increase the replica count, set up your backups, and then schedule a full backup at midnight and differential backups every 6 hours during the day. Simple to do. On the right here, you can see that we've got the command line interface, communicates with a container that provides a REST API. That communicates with a container that has the operator, and then the operator might make use of another container that handles the scheduling. Real brief, not enough time in 5 minutes to go into this, but this is the type of cluster you can deploy with these simple commands. High availability cluster across all of your OpenShift. And this is where it's available. The operator is available, as I said before, GitHub, CrunchyData, Postgres Operator. We've got a table in the other room. Please stop by and see us.
Well done. Thanks. Perfect.